I wanted to take some time to review a really old topic with you, linear programming, because it's on your final exam. Your final is cumulative, which means it includes everything throughout the semester. It's not heavy on your final exam because you've already been assessed on it on your midterm, but there are a few questions, so I think it's worth review. So watch this quick video, do the examples in your workbook as I go over them here, and then you'll have some time to practice as well. So in terms of your workbook, the examples that I'm going to do are on page 7. For some reason, your workbook didn't pick up on the page numbers. So when I say page 7, like the front cover would be considered 1, the back cover is considered 2. So then you'll have polynomials, that's 3 and 4. And then you'll see rational exponents and expressions, that's 5 and 6. So 7 will say linear programming. So these are where the examples are that I'm doing, and I'm actually going to do examples 5 and 6 because if you can do a system, then you can do a single. So this example is on page 7. I want to take my time to graph each of these lines separately. So the first line that I'm going to graph is y equals 4x plus 1. I'm actually going to ignore the inequality and just graph 4x plus 1. This line is called slope-intercept form. It's y equals form. So in slope-intercept form, the first thing you want to do is plot the y-intercepts. And the y-intercept is the one that doesn't have the x with it. So that's the 1. So on the y-axis, which is the up and down axis, I'm going to make a point at 1. The next thing I'm going to do is I'm going to look at the slope, and I'm going to make the slope a fraction if it already isn't 1. So this one's 4, it's not a fraction, so I'm going to make it 1 by putting it over 1. The top is going to be my up or down number, and my bottom number is always going to be right. You never want to plot a point to the left. Now, because the top is positive, because the 4 is positive, it's going to be an up. So from my point 1, I'm going to go up 4, 1, 2, 3, 4, and right 1, and that's where my next point is going to fall. I can do that again, 1, 2, 3, 1, 2, 3, 4 over 1. You don't have to though, it only takes 2 points to make a line. So once I have my points, I'm going to take my ruler, and because this inequality is not inclusive, I'm going to connect it with a dotted line. So if you already did this and you made it solid, just erase certain parts of it so that it's dotted. All right, so there is my first line. I am going to hold off on shading this line. That's not great. I'm going to hold off on shading this line until I get the second line plotted. All right, the second line here is y equals 2. This is a special line. A y equals line that has no x technically is like y equals 0x plus 2. All right, so I'm going to plot the y-intercepts, which is the one without the x, which is the 2. So I'm going to make a point on the y-axis at 2. And then I'm going to create my slope, which is 0, and because my slope isn't a fraction, I'm going to put it over 1. Remember, we always go right based on the bottom number. The top number is going to be up or down. Now, in this case, it's not going to matter if I say up or down because I'm not going anywhere. So I'm not going to go up or down from this point, my y-intercept. I'm just going to go right 1. And I continue to go right 1. A y equals line that doesn't have an x value or a slope with it is a horizontal line. Now, because this inequality is inclusive, I'm going to make this line solid when I connect it. And that's going to go right through too. That's not great. So there's my line. All right. Now, what this did was it broke my graph into 3 regions. I'm going to label them. 1, which is this top left, 2, 3, and 4. Only one of those 4 regions is going to get shaded in, and that's where my testing comes in. And I'm going to test this point down here, which is 0, 0. So when I'm testing it on the red line, I'm going to plug 0 in for the y. I'll keep the inequality the same. 4, 0 in for the x, plus 1. So I end up with 0 is greater than 4 times 0 plus 1. 0 is greater than 1. Well, that's not true. So here's what that tells me about my red graph. The green dot is in a non-true spot of the red graph. And the green dot is in region 3. So the answer is not going to be region 3. The green dot is below or to the right-hand side of the red line. So anything on that side of the red line is not going to be true. So number 2 isn't going to work either. I know that my answer is either going to be 1 or 4 based on the red line. Now I'm going to check the blue line. So I'm going to take the inequality. 0 is less than or equal to 2. I'm only replacing the y because there's no x. And this is actually a true statement. So my green point is below my blue line. So everything below my blue line is true. So 3 works for the blue line and 4 works for the blue line. Everything above my blue line is false. So this doesn't work and this doesn't work. So my region that works for both is region 4. So the region that's going to get colored in is region 4. All right, let's try one more like that. And this is example 6. So the first thing I'm going to do is I'm going to graph the line negative 7x plus 3y. Instead of less than, I'm going to put equals negative 21. And this is a line that's called standard form. To graph a line in standard form, you need to find the x-intercept and the y-intercept. To find the x-intercept, you take the equation's x part and then you ignore the y part. So the plus 3y I'm not going to write. I'm only looking at the x portion of the equation. And to find a y-intercept, I'm going to ignore the x part and I'm only going to solve the y part of the equation. And I'm solving each of these equations to get the variable alone. So the x-intercept is 3. So on the x-axis, which is the horizontal one, I'll make a point at 3. And the y-intercept is negative 7. So on the up and down axis, I'll make a point at negative 7. It only takes 2 points to make a line, so I can connect these now. Just keep in mind, because this doesn't have a line with it, when I connect these, it's going to be a dotted line. That's a little off, but close enough. All right, so then I am going to graph the next line, which is x is equal to negative 4. This is a special line. Remember that the y equals line from the previous example was a side-by-side line. This is a vertical line. That goes through the x value of negative 4. So I'm going to make a point on the x-axis at negative 4. And then I'm going to make this line vertical, meaning I'm going to make it go up and down. So I'm just going to pick some points above it and below it so I can use my ruler to make that straight line. Now this is going to be another dotted line because that is another not inclusive inequality. So when I connect these, it's another dotted line. Now based on my graph right here, I actually only have 3 regions. So I'm going to number my regions. I've got this region on this side, this region in the middle, and this region over here. Most of the time it works out that there's 4. This particular example would have had 4 if I had more graph. But since I don't, I'm looking at these 3 regions. And I'm going to test 0, 0, which is smack dab in the middle here. By plugging it in. So I'm going to do negative 7 times x, but I'm going to put a 0 there, plus 3 times y, but I'm going to put a 0 there, is less than negative 21. So 7 times 0 plus 3 times 0 is less than negative 21. 0 is actually not less than a negative number. I'd rather owe nothing than owe $21. So this is a false statement. 0 is greater than 21. So when I think of this false statement, I need to be focusing in on the red line. In terms of the red line, this is false. So everything on that side of the red line is also false. So region 2 is on that side, so that's not going to work. And region 1 is also on that side. So I'm thinking the answer is going to have to be 3 here, but I'm going to check the next one just in case. So I'm going to plug 0 into the second inequality for x because there's no y. And I get 0 is greater than negative 4. And that's true. 0 is greater than negative 4. So the blue line, I want to shade towards the 0, 0, which is this way. Anything away from the 0, 0, which is this way, is false. So region 1 is in an area that doesn't work. 2 and 3 will work for the blue. And so you see that 3 is the region that works for both. So that's the region that gets colored in here. So at this point, you've seen one of each type of graph. A slope-intercept form, and here's how you do it. A special graph, y is horizontal. A standard form, you're going to find x and y intercepts, or a special graph x, which is up and down. This should allow you to be able to do practice of all types of graphs. The last thing in linear programming that you're going to need to remember for your final is how to define variables and constraints. So first thing you do is you read through the example. This one says, Monica is a college student who wants to make money over the summer. She has 2 part-time jobs. Monica earns $10 an hour as a camp counselor and $11.50 an hour as a clerk at Five Below. Monica can work at most 16 hours per week at Five Below. How long should Monica work at each job if she wants to earn at least $400 a week? So remember from this unit that the variables come from the question. So I'm looking for the question word. How long should Monica work at each job? So her variables is how long she should work at each job. So it would be how long, or hours, she should work at each job, which would infer that there's more than one type of job. So let's see, she's got camp counselor, and then how long her second job is Five Below. So that takes care of the variables. If you remember from this unit, the first 2 inequalities are always the same. X is greater than or equal to 0, y is greater than or equal to 0, because she can't work negative hours at either of these places. The next thing I want to do is I want to go through and find the 2 biggest numbers in the problem, the 2 biggest numbers that are left in the problem. 16 is one of them, and 400 is the other. I want to put those numbers at the end of these inequality lines, and I want to label what they mean. 16 is hours. This creates categories for these 2 equations, which is going to help me figure out where the other numbers go. The 2 numbers left are 10 and 1150, and both of those numbers have money with them, which means I'm going to put them in the money equation. And I'll put them in the order I found them. 10 is camp counselor, which we said is x, and 1150 is Five Below, which we said is y. Which means there's nothing left for this 16 equation. Sometimes it will be x plus y, sometimes it will be just x, and sometimes it will be just y. It depends on what the number is. This number is 16 hours a week at Five Below. It's specific to her Five Below job, which is specific to our y variable. And then the final thing I have to do is look at my inequality words. At most means the most she can work is 16. So her hours need to remain under 16. So this would be a less than sign. And then for her money, she wants at least, which is the opposite. The lowest she wants is 400, so she wants more than or equal to 400. What you're gonna do now is try some examples in the review guide. But again, because the pages got messed up in your workbook, I'm gonna show you what I mean by that. It's page 13 and 14. And so it's not section 4 geometry, it's not probability warm-up, it's not factoring warm-up, it's not rational expressions warm-up, it's after that. It says review guide. Okay, so you're gonna do the review guide, numbers 1, 2, 3, and 4, all graphing, and then this is all number 1. 2, 3, and 4 are all setting up the constraints. These are all examples that we just went over. So complete the problems on your own. There's an answer key on the backboard. There's video explanation on Canvas. And if you finish early, eventually all of this review guide is going to be work. So all of the remaining review guide is all of this. It's the rest of the packet here. Except don't do multiple choice practice. So it's the rest of the packet through example 17. So you can work on that. And the answer key for that is on Canvas as well.